Okay. 13.4, the 6 trigonometric functions. So determine the values of the 6 trigonometric functions from a point on the unit circle. So in section 1.3, we learned about the unit circle, and we learned that sine is y and cosine is x. And so we learned how to find those points and how to find sine and cosine. Well, it's time to take those values and find all of the others: tangent, cosecant, secant, cotangent. We're going to learn some more identities in addition to the Pythagorean identity. We didn't really get to it in class last time, but I did record a video, so make sure you go back and learn about that Pythagorean identity and using it. But here's a few more identities. Trigonometry is known for identities, which are like equations or rules or formulas that we use for a lot of things. We have a chapter coming up later in the semester that will just focus on identities. Okay, and then we're going to find angles that satisfy trigonometric equations. So that will be kind of going backwards. If we know the value of a trig equation or a trig function, we should be able to go backwards and identify the angles that would get that ratio. Okay, so here they are. We already learned that sine is y, cosine is x, tangent would be y divided by x. So I like visual representations. So just quickly, we've done a lot of those, but just to make sure. So like, yeah, I guess that works. I want to flip it a little bit though. Flip it this way, because then it would be just a quadrant 1 angle, right? So this would be y, which is the opposite side, and this would be x, which is the adjacent side, and this would be 1, because we're just using the unit circle, right? So that means opposite over adjacent is tangent, so that would just be y over x. And then for cosecant, it's hypotenuse over opposite. It's the reciprocal of sine, so it would be 1 over y. And then for secant, it would be 1 over x, because that one's hypotenuse over adjacent, which is the reciprocal of cosine. And then cotangent would be x over y, because it's adjacent over opposite, which is the reciprocal of tangent. So just wanted to show you on your blue charts, I put these little boxes up here, so you could just have this all on one page for your convenience. So sine is y, cosine is x, tangent is y over x, cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. Okay. We're going to be learning these other identities. You can put them down here on this paper if you want to. So last time we learned the Pythagorean identity, so that was that the sine squared theta plus cosine squared theta equals 1. Now there are actually 2 other versions of that Pythagorean identity. I don't think we need to know those right now. It might come later in this section. We'll know when we get to the examples and stuff, and we'll talk about it today if we need to. Otherwise, I know it's somewhere in this chapter. Okay, so we're going to come back and fill these identities in here in just a second. So moving ahead in our notes, we have the quotient identities. So since tangent is y over x, and sine is y, and cosine is x, that means that tangent can just be represented by sine over cosine, right? And since cotangent is x over y, and cosine is x and sine is y, cotangent could just be represented by cosine over sine. And then we've talked about this before, these reciprocal identities. Since cosecant is hypotenuse over opposite, and sine is the y value, that could just be rewritten as 1 over sine. And then since secant is 1 over x, we could write that as 1 over cosine. So I don't know if you noticed this, but every single one of our trig ratios can be written in terms of sine and cosine. So as long as you know the sines and cosines of everything, Ta-da! These that we talked about earlier, you can find everything else. So memorize, great. Know how to find them from memorizing less? Perfect. It doesn't matter. Whatever works best for you and the way your brain learns things and recalls them to show that you know what they are. Okay, so let's go back and fill these in our little blue chart. Let me make sure my pen is selected. Here we go. So sine, let's see, is it still skinny? No, it's not. I just want to be able to write small. So tangent would be sine over cosine, and cotangent would be cosine over sine. And reciprocal functions would be 1 over sine. I know sometimes it's tricky to remember that sine goes with cosecant, and secant goes with cosine. Just one of those weird things to remember. Okay, so we're building a nice little repertoire here of identities that are going to be very useful for us along the way. All right, we haven't even gotten to any examples yet. We've just been going through the details of what we're learning, but I'm going to go ahead and end this video and we'll start a new one just for the examples.